Hello everyone, welcome back to Math Bison. Today we are continuing on the foundation of algebra, and we are going to look at how to model algebraic expressions or numeric expressions. Hang on and let's continue in a moment. So how do we model? And we gave examples of these expressions, like having x plus 3 is an example of what? Algebraic expressions. If we have 2 plus 1, it is an example of what? You want to try. It's numeric expression because there's no variable. There's no letter, no letters in this expression. And so on and so forth. So today, this is not our focus. We are focusing on what? How to model mathematical expressions. So, assuming that we have these three columns, let's say we have a word phrase and we are trying to model it here. We want to put the model here. And we will look at the outcome of the model, which is the expression. So, something new here, we have discussed word phrase before. We have also discussed expressions before. But now we have model coming in. So what do we imply by modeling? In mathematics, when we model, we think about how to visualize using pictures or pictorial visualization of expression. If somebody says something, can you picture it in your mind? What sort of pictures, relevant pictures or images can you bring together to help you understand what the phrase is all about? This model will also help us to do some manipulation, and it helps us to also put things in perspective, meaning that it can help us to maximize our accuracy of expression if we can visualize what the phrase is all about. So let's get into it. Getting into it. Let's take a first example. For example, we say, let's use an algebraic expression, say m plus 3. What does it give us? If we're looking at m plus 3, we can think of a full stretch of a line that stretch across to mean the result that we get when this variable is added to 3, or when 3 is added to the variable. So there is limit. We have this limit. We have a limit on the left and a limit on the right. It cannot be infinite and it cannot be endless. But whatever happens must happen within this limit. So how do we create a model? Now, within these boundaries, we want to have an m, which is a variable. So this variable, I can just represent it with, let's say, a box, which we call m. And we're going to have part of this box, or let's say a second box, that is what? That will stretch to the other boundary. Yes. Such that this first box will mean m and the second box will be 3. So we are saying that whatever you get is going to be equal to this line up here. This pictorial representation of this phrase is what we call expression. It's what we call a model. So this is the model of this word phrase. And if we want to put it in expression, what does it become? This is going to be, we're supposed to use expressions like words. So I can say 3 more than a number. So this should be 3 more than, yes, we are speaking plain English, more than a number. So this is the 3 more than a number. This is the number. That number is m. And what is happening? 3 is more than that number. 3 more than a number. So we need to know the number, then we add 3. So what does it give us? This is what is represented by the question mark here, which is the full stretch of this line boundaries. So in the expression, we can transfer this to this side of the expression. Okay, so we have m plus 3. So that is the expression. So for us to understand this further, we can go into a second example. So in the second example, what if we have like 6 less a number f? That is, f hardly come up in our algebraic expressions. Of course, it's always, usually we see x more often. Of course, we also have maybe in polynomials or in quadratic equations, we do have f also coming. And in some formulas in maybe physics and advanced mathematics, we do have a lot of f too. So let's take the second example. The second example is what? Let's say 5 less a number, and that number is f. What is 5 less a number f? This might look very abstract, and it might be hard for some of us, some of our learners. But for us to understand what this is all about, we can try to model it, create a model, a mathematical model, a visualization that can represent perfectly what this word phrase is all about. So I know that I'm going to have 5. In this case, the expression is different. 5 comes first and it's less. So we are taking a number from 5. So what we'll do is we'll first of all draw our full stretch of line. And we already know that full stretch, it is 5. It is not more and it's not less. So this time around, something is going to be taken away from it. Then we are asking what is going to be left after we take this particular f from it. F is not known. It's a variable. It can change. So we can have f in this manner. And we have the other part in this manner. Okay, so this is going to be f, which we are going to take, which is we're going to subtract from 5, and it's going to give us this other aspect, this other part. So how do we, with this model, with this picture, with this diagram, we are able to say that we're able to tell ourselves that the full stretch within the limit that we are given is going to be 5. But this 5, there's a particular number or quantity which is not mentioned. But because it can change, it could have been 3, it could have been 2, it could have been 1, it could have been 0, it could even be 6. Sorry, yes, in some cases, it could be 5 itself. Okay, so what is going to be left after that? But by the way I have drawn it, if it's going to be 5, then this initial f may have to stretch way further to the end of this. So let's assume that we are limiting everything to like 1, 2, 3, 4. So what is going to be here? So that the sum of f and that number